So now we're going to put everything together that we've talked about so far. We're going to actually figure out the length of an unknown side length. And we're going to combine things that we've started with. The first thing that we looked at was how to properly name a triangle. So we're going to do that here. Next, we talked about what are the primary trigonometric ratios, sine, cosine, tan, okay, and what those things mean. Then we looked at, well, what does sine of 30 degrees actually mean? And we've discovered that sine of 30 degrees is just representative of some large decimal number. So it's just a number. So sine of 30 degrees, cos of 50 degrees, tan of 26 degrees, they just represent a decimal number each. So now we're going to put those three skills together, and we're going to use them to figure out, well, what is the length of this side right here, of this particular part of the triangle. Okay? And so as we go through, we need to make use of all of those things that we've done. So first thing that I want to identify is let's properly name this triangle. Okay? So we need to identify first the hypotenuse. So our hypotenuse happens to be equal to 20. Okay? Then we know that we have an angle, and our angle is right here. It's 23 degrees. So what's the opposite side? Well, it happens to be the side that is across from that 23 degrees. So the opposite is our x value. And that means that our adjacent side is down here. Now, the next thing that we need to do is we have to figure out, okay, I know there's three trig ratios, sine, cosine, and tan. Which one do I use? So one thing that I like to do is I actually want to write out SOHCAHTOA, and that'll help us to identify, and through a process of elimination, what we need to do. So I'm going to write in SOHCAHTOA. Okay, so there's my SOHCAHTOA. Now, first thing, I want to start off by identifying what is it that I'm looking for. Well, I'm trying to figure out what this x value is, and the x value happens to be equal to the opposite value. So I'm actually looking for the opposite value. Okay, so I'm going to put a line underneath the O's that are in SOHCAHTOA. Okay, and by doing that, I know that I have to either use the sine ratio or the tangent ratio. I can't use the cosine ratio because cosine ratio is not going to give me information on the opposite side length. So I, first off the bat, am able to eliminate the cosine ratio. Then I got to figure out, well, what information do I already have? Okay, and so the first letter in each of the three-letter groups in SOHCAHTOA represents the angle. So here my angle is 23 degrees. So I actually have sine of 23 degrees, or potentially I have sine of, or tan of 23 degrees. So I have an angle, and that's really helpful. The other thing that I do have is I also know the value of my hypotenuse. So I know that my hypotenuse is equal to 20, but I don't have an adjacent side length. So I can't put a check mark above the A in the TOA piece, which means that I have to have 2 of 3 pieces of information along with what I can actually find. So this means that out of all 3 options, the only sine function that will allow me to solve this problem is the sine function. It will help me to figure out what the opposite side length is. I have sine of an angle, and I also have the value of the hypotenuse. I can't use cosine because it's not going to help me figure out the opposite, and I can't use the tangent function or the tangent ratio because I don't have enough information. I only have 1 piece of given information, and you need to have 2. So you always have to have 2 of the 3 pieces of information. So what I'm going to do now is I'm going to actually write out. I know that sine of an angle, okay, so sine of any angle is equal to the opposite divided by the hypotenuse. So now what I'm going to do is, now that I've decided that and figured out that I need to use the sine ratio, I'm just going to start subbing information in. So I'm going to put in sine of, I've got 23 degrees. So I'm going to put in sine 23 is equal to the opposite side length. And so my opposite side length is x. and the value of my hypotenuse is 20. Okay, so 20 units long. So now I've substituted in the 3 pieces of information that I need, the 2 pieces that I know for sure and the 1 piece that I'm looking for. Okay, and so what I need to do is actually solve this now. And one thing that we need to be aware of is that any number can be written as a fraction. Okay, and so sine of 23 degrees, we know that sine of 23 degrees is just equal to some decimal. But moreover, not only is it equal to some decimal, but again, any number can be written over 1. So for example, if I had a decimal that was, say, 0.5, I could divide that equally by 1. Okay, so 0.5 divided by 1 is still 0.5. They're equivalent, but I can write it as a fraction. And the reason I'm going to write this as a fraction is that this will allow me to do cross multiplying. Okay, so we've actually got sine of 23 divided by 1 is equal to x divided by 20. So this now is a proportionality statement. We need to figure out what x is, and we actually have one complete proportion. We have sine of 23 degrees divided by 1. That is going to equal one complete fraction. So I'm actually just going to cross multiply, just like I would have done in some of my earlier skill building questions. So I'm going to take sine 23 and multiply that by 20, and I'm going to take x and divide that by 1. So I'm going to actually get x is equal to 20 times, and I'm going to put sine 23 in brackets, sine 23. Okay, so, well, that's all well and good. I know that 20 times sine 23 is going to be the length that I need. So what do I need to do? Well, in my calculator, I'm going to put in 20 times sine of 23, and I'm going to hit equals. And that's going to tell me that my x value, the length of side x, is approximately 7.8 meters long. So we're going to follow the exact same process again to solve this second example here. We've got in section B something very, very similar. So let's look at triangle B, or the triangle in question B. So in question B, again, we're going to go through and we're going to identify, well, which primary trig ratio should we use. So I'm going to put in ka toa. Okay. Next thing I want to do, I want to label this particular triangle. So start off by labeling the HOA. So my hypotenuse is directly across from the 90-degree angle. My opposite side from the angle given, so I'm given 33 degrees, and so the side across from that must be my opposite. And so the last side, therefore, must be the adjacent side. So now I've labeled my HOA. So now I got to figure out, well, what side length am I trying to solve? Well, in this case, I'm trying to solve for length x, this horizontal line segment at the top of the triangle. So side x represents my a value. So that's what I'm starting to look for. So I want to figure out, well, I'm going to underline all of the a values. Okay, so automatically I know that I can't use the sine ratio because it won't allow me to solve for the adjacent side length. So I'm actually going to cross out the so piece. Then I'm going to look at, well, what information do I have? So I have 33 degrees. Okay, so I could have cos of 33 degrees, or I could have tan of 33 degrees. So I'm going to put a check mark above both of those things. The other piece of information that I have is I know the length of my hypotenuse. So I can put a check mark above that. Now, do I know the length of the opposite side? No, I do not. And therefore, the ratio that I have to use is the cosine. I can't use the tangent ratio because I don't know what the value of the opposite side length is. So now that I've determined that I need to use the cosine ratio, I'm going to go in, I'm going to start filling in my blanks. So I've got cos of any angle is equal to the adjacent side divided by the hypotenuse. Okay, and now I'm going to substitute in the values that I know. Okay, so here I've got cos of 33 degrees. That's equal to my adjacent, which in this case is equal to x, and that's being divided by the hypotenuse. And I know that my hypotenuse is 9. Okay, so same deal as before. I can set this up as a proportion. Cos 33 degrees, the same as writing cos 33 divided by 1. Okay, and so now I actually have a proportion, and I can use cross multiplying to help solve this. So if I go through and I cross multiply, I'm going to multiply cos 33 by 9, and I'm going to multiply x by 1. And so when I do that, I end up with x is equal to 9 times cos 33. And so if I want to now simplify this further, I'm going to need to use my calculator because I don't know what cos 33 is equal to right off the top of my head. So I'm going to type in 9 times cos 33, and then I'm going to hit equal. And that's going to come out to approximately 7.5. Okay, so the length of side x happens to be approximately 7.5 units in length. Okay. So one final example. Again, same process as we've already gone through, and you're going to just continue to repeat this process and get better and better with it. Okay. So let's just quickly complete this triangle, which for some reason didn't complete itself. So in this instance, I want to figure out one of these unknown side lengths. So let's try and figure out, well, what is the length of, let's call it x. Okay. So if we want to figure out the length of x, again, we got to go through and use our process. So first thing you want to always do is label your HOA. So here we've got our hypotenuse. Terrible H. I'm going to try and do that again. Okay, so I've got the length of my hypotenuse. I can figure out my opposite side length, and so therefore the x must equal the adjacent side length. So now I'm going to go through and I'm going to solve for this. So I want to first identify, well, what ratio should we use? So I can go ka toa. Okay. I'm trying to figure out my A value. So I'm going to underline that. That's going to eliminate the sign ratio. I know that I have the angles, and I know I have a hypotenuse. So that means that I must therefore use my cosine ratio. Okay, so now that I know I got to use my cosine ratio, just like I did up top here, I'm going to put in cos x is equal to the adjacent divided by the hypotenuse. So now I'm going to substitute in my angle. My angle happens to be 23 degrees. And that's equal to the adjacent side length, which is x, divided by the hypotenuse, which is 20. Okay. Again, I can write cos 23 as cos 23 over 1. And then I'm going to cross multiply. So I'm going to do cos 23 times 20 and x times 1. So that leaves me with x is equal to 20 times cos 23 degrees. Okay. And then if I simplify this, I'm going to get 20 times cos 23 is equal to approximately 18.4. Okay, and so again, putting together all the skills that we've done so far, you want to first label your triangle. Second, write out your SOHCAHTOA, identify which trig ratio you're going to use. Then you're going to substitute and you're going to solve.